Okay, let's one available is okay. Let's start the class. Um, a very good evening, good late afternoon to all of you. I welcome you all to this fifth week discussion or problem solving session. Um, uh, so this course is fundamentals of electrical engineering and is being taken by Professor Debapriya Das, and I am Swastik Sharma, PhD or PMRF scholar at IIT Kanpur. Screen is visible, yes. Okay. Okay, in the last week, we started discussing about circuit theorems, but first we discussed about one linearity property of a circuit. So for a circuit to be linear, it has to follow principle of homogeneity and principle of additivity. Where homogeneity is, if we scale the input, the output has to be scaled by that number only. And additivity, if we add two, if I add two, if I add two values of the similar circuit component, like for example, if a circuit has V1 voltage and I1, so let's say if a circuit has V1 voltage and it's a resistance V1 voltage and some I1 current, and it has V2 voltage with some I2 current, and if V1 plus V2 equals to V, where V is equals to capital IR, therefore I1 plus I2 is equal to I. This is the property of additivity. Okay. Then we discussed superposition theorem. In superposition theorem, it's based on the principle of linearity only. I mean, all the circuit theorems have to be followed by linear circuits only. So in superposition theorem, we take one independent source at a time and calculate the effect that it has on that circuit element, and we add all the and we do the algebraic sum of that circuit values, and we come up with the final values, right? And third, we discussed after superposition, we discussed source transformation. In source transformation, we said it's based on the fact that if a circuit is equivalent in nature, it's based on the concept of equivalence, that if a circuit has similar VI characteristics to that as that of the original circuit, we can transform it to, um, to that circuit. Like for example, if I have a voltage V in series with R connected between two terminal 1 and 2, we can represent this two terminal circuit with this, where if it follows the concept of equivalence, V must be equal to I R. Okay, now we'll move on to the two main theorems of circuit analysis, which are the backbone of all the circuit theorems. These are Thevenin's theorem, and second is Norton's theorem. So first we'll look why we need these two theorems and what is it that we want them to do. For example, if we have a linear two terminal circuit, make note of the fact that I'm saying linear again and again to stress on the fact that these circuit theorems are only applicable to linear circuits. So, yeah. So let's say I have a household load. So we have multiple appliances, right? We have multiple, what we can say, circuit elements connected to that one source. So if all of the circuit elements are, let's say, constant in nature and we have one variable load, so to solve that again and again for different varying values of that variable load, we won't solve the circuit again and again, right? We would want to reduce that linear part of that circuit to a sort of an equivalent circuit, which can be, so that effect of it can be looked at the circuit level, right? So in Thevenin's, what we do is we reduce the linear. Let's say if I have first, let's say we are looking at Thevenin's theorem. So if I have, let's say, a two-terminal circuit, which is supplying some varying load, this resistor with a arrow on top of it means that my load can vary. Okay, we can represent it a voltage source called a Thevenin voltage source in series with a resistance called Thevenin resistance. With my load impact, right? So what we did, we removed that load and we reduced the linear circuit to a voltage source called Thevenin voltage source and a resistance called as Thevenin resistance, right? Now, okay, this was okay, yeah. So it's an essential tool because we want to reduce if this linear part of the circuit is quite huge, we want to reduce it to a simpler equivalent circuit to make the analysis a bit easy for us. Okay, this is Thevenin's theorem. So how do we calculate VTH and RTH? First, we'll see. How. Hmm. So what we do is we look at the same circuit. Hmm. And we find the open circuit voltage across the two terminal, removing that load, right? And the circuit remaining intact. This open circuit voltage is nothing but Thevenin voltage. And similarly, to find RTH, so we'll quickly go through Thevenin's theorem and Norton's theorem, and then we'll do some sample problems based on week 5 assignment. So here the circuit will no more remain intact. What we'll do is we'll turn off independent sources. Remember, only the independent sources are turned off, not the dependent sources, because yeah, because the dependent sources have the values dependent on some
From the very beginning.
yeah. You were saying, Ganesha?
Can you start from that? wasn't present in the class.
I don't get you. What were you saying? Can you write it in the chat box? I can see. Yeah. So till then I'll continue. So RTH is the equivalent circuit. So where was I? Yeah. Dependent sources are not turned off because they are dependent on the circuit variables. So we left them we leave them intact. Yeah. Okay. Now if a circuit has dependent sources, right? Part is yeah. Did you write it in the chat box? Now for the dependent sources, since we are yeah.
Sir, how to calculate R Thevenin start from the beginning time, please?
Okay. Yeah. Okay. So we'll look at two things so just R Thevenin, right? V Thevenin is easy. You just calculate the open circuit voltage. So bear with me. I'm just explaining this part, but we'll solve some problems and then we'll get the hang of it, how to find the R Thevenin, right? But if you want to see how we do it in the theorem, it's like when we have independent sources, we turn off them. By turning off, we mean the voltage sources are replaced with their internal resistance, which is zero in this case. So that means we short circuit them. And for current sources, we open circuit one. All right. So that's how so once we do that, then we calculate the equivalent resistance value of that circuit, and that is equal to the Thevenin's resistance, right? But if we have dependent sources, what we do, we turn off the independent sources. That means we replace them with their internal resistances. Voltage sources are short circuited and current sources are open circuited. And since they are dependent on some values, what we do, hmm. So what we do, we add a voltage source or a current source, right? Let's say we add a voltage source, V naught. Then for that V naught, we try to find the current I naught, and the R Thevenin is nothing but V naught upon I naught. Okay. Or we can do one thing, we can add a current source. So don't worry if you're not understanding. We'll solve some questions. You will get the hang of it, how we do it. So we calculate. So we give an I naught at the terminal, and we calculate the voltage around it. So R Thevenin is V naught upon I naught. Okay, so that's how we do for Thevenin circuit. Finding the Thevenin's resistance if we have dependent sources in the circuit. Remember, we turn off the resistance, we turn off the independent sources, and then we apply a voltage source at at the terminals, or a current source at the terminal, and then we calculate the current or the voltage around it, and then we can easily find the Thevenin's resistance. Okay, so we'll quickly go through Norton as well. Norton is quite similar to it. So in Norton's theorem, what we do is, instead of representing the two-terminal circuit as So instead of representing our two-terminal circuit as a voltage source in series with a Thevenin resistance, we represent it as a current source in parallel to Thevenin's resistance. And you must be feeling that it's just source transformation, right? And that's where source transformation gets its name from too. Source transformation is also called as Thevenin-Norton transformation. So keep that in mind. So what we do, we represent it as Norton current IN in parallel with a Norton resistance or a Thevenin resistance. Both are same. When we do source transformation, the resistance remains same, right? That's why a Norton theorem or a a Norton resistance or a Thevenin resistance is same. Rn is equals to RTH, and the methodology of calculation also remains same. Yeah. Any questions till this point? Okay. So now, how do we calculate IN? Right. That must be a question popping in your mind. How do you calculate IN? So any idea? Any idea? Any one of you who can tell me how do we calculate IN? So it's source transformation, right? Just keep that in mind and then tell me how can we calculate IN? Anyone? Okay. So what we do, we short circuit these terminals 1 and 2 where the load is connected, and then we calculate that short circuit current. And IN is nothing but Norton's current is that short circuit current around that terminal. And the methodology of calculating the Thevenin's resistance stays the same as was in the case of, Norton's resistance stays the same as that was case with Thevenin resistance because the resistance is the same. One more important fact, since I told you that it's source transformation, right? If I represent a Thevenin circuit as this VTH, RTH, doing source transformation or Thevenin Norton transformation, I'll get this circuit, right? And Rn is equals to Thevenin resistance. So that means, therefore, so Rn or Rth is nothing but Vth by In. Am I correct? Since in source transformation, what we do? We do Vth is equals to In Rth, and Rth is what? Vth upon In. So the Thevenin resistance stays the same. Okay. Now last I want to discuss is maximum power transfer theorem. So at times you'll find yourself in the situation where you want to maximize the power being transferred from the source to the load, right? So how do we do that? I mean, in terms of Thevenin, if I have a linear circuit, linear two-terminal circuit, and I reduce it to a Thevenin circuit, which is a voltage, Thevenin voltage, in series with a Thevenin resistance. So what is the how can we transfer maximum power? What at what value of the load resistance would the maximum power be transferred? At what value of RL or load resistance will the power delivered by source be maximum? So let's take a Thevenin circuit with a Thevenin voltage in series with a Thevenin resistance applied across a load RL, right? And let's say this load RL takes IL current. So quickly, can anyone tell me what is IL? Renessa, what is IL? IL is VTH upon RTH plus RL, right? And load power is denoted as IL square RL, which is nothing but VTH square upon RTH plus RL whole square into RL. So Renessa, do you have any problem up until now? Can you just give me a confirmation? Renessa? Okay, since there is no we'll move ahead. So how do we find the value of RL at which PL is maximum? So what we do? So just a second. Let's see it in this way. So if I draw a power versus load value curve, it is something like, just believe me when I say it's something like this, right? And we want to find this maximum value of RL. We want to find what is the value of RL at which load power is maximum, right? So how do we do that? So as you can see at this point, uh, the the slope is zero, right? The slope is zero. So what we do, as slope is the differentiation of that curve with respect to RL, will equate it to zero, right? So using the differentiation formula, we get VTH square. So it's numerator square, right? Denominator squared would be 4. And firstly, RL, RTH plus RL whole square minus RL. And then RTH is nothing but 2RL, RTH plus RL into 1, right? And equated to 0. So the numerator equating, so then say you went offline. So what I was discussing is PL and RL have this curve between them, right? And to find out this maximum value as the slope at this point, let's say RL is equals to X. At this point, the first differentiation of that curve to 0, right? This is slope of the curve. And we equate it to 0. So once doing that, we know the differentiation, how we do differentiation. It's denominator squared. And first we multiply the denominator with the differentiation of the numerator, which is just RTH plus RL whole squared. And we then take the numerator multiplied with the differentiation of the denominator, which is minus 2RL RTH plus RL, right? So we now equate the numerator to 0, which is 2RL RTH plus RL. This would be 0. RTH is therefore equal to RL. So that means at RL equal to RTH, the maximum power that is being transferred from this Thevenin voltage to this load is maximum, right? So let's find out what's the maximum value. P max is what? Equate equating 2 in 1. So what is it? VTH square 4 RTH square into RTH. Okay, so it's VTH square by 4 RTH, right? So that's how we find the maximum power transfer. So any doubt up until now? So now we'll start questions. So if you have any doubts, you can clarify. Any doubt, Vanessa?
And
Mm-hmm. Your connection is very bad. You can use a
I'm
chat
listening
box.
to half of.
Mm-hmm. Yeah, yeah.
Sir, in the previous class, there was a question which was done, so I got a different answer to that.
Oh, okay. So, can we discuss at the last? Okay, so you want to discuss it first. Let's discuss it then. Which question
You do
exactly?
the today's one only so that I can do the assignment, then we can discuss at the last, sir.
Okay, yeah. So we'll first discuss the sample problems based on week 5 assignment because it's important. If you don't know how to solve Thevenin's theorem or Norton's theorem, it would be difficult for you to solve that assignment. So I can't stress this fact enough because the week 5 assignment is based mainly on that two theorems, right? So let's do sample problems. By the way, you must have received week 3 and week 4 solution sheets, right? So you don't, I guess you don't have any doubts in that two assignments. Yeah. So let's start. Please try to answer so that it's a lively class. So first question. So can you tell me how we can solve this question? I mean, it's Thevenin's equivalent network we have to find out, but can you comment on the circuit, the nature of the circuit? You're able to see my screen, right? Yeah, you're able to see my screen.
So we will be taking this part to that using this book.
Mm, can you come again? Can you please? Yeah. Continue. Okay, so see, Renessa, what we do is we calculate the open circuit voltage, right, across the two terminals. But is this circuit legit or is this circuit even possible with 5 ampere current source? Can I have it open circuited? It's one terminal is open, right? We can't have it. This circuit is not possible. This circuit is not possible as the connections are invalid. So we can never open circuit a current source. So A and B are open circuited. We can't calculate the open circuit voltage. And RTH also we can't calculate because since 5 ampere would be open, RTH would be zero. So the answer is none of the above. I had this question just to clarify that you have to check every time you solve a question. You just don't start solving it. See for yourself if that circuit is even possible. If it's not possible, you just have to. So you have to keep your eyes open and then comment on that circuit. So the answer would be none of the above. The sole purpose of this question is to check if you know the law of connections, as the connections are invalid. Sorry.
Sir, I said, but you didn't listen.
Oh, you said sorry. I must not have. Oh, your voice is breaking. Okay, now we'll solve this question. So, any idea how we can solve this?
Uh, we just take the load and then we'll be removing it with different circuit. And then we can move forward accordingly.
So we can reduce the circuit into its Thevenin's form, right? So what would be its Thevenin's form considering the Thevenin voltage is VTH and resistance is RTH? This reduced circuit would be something like this. Oh, sorry. Right? And then you have this moving coil meter, ammeter, or whatsoever. We won't write it. And we have R. Sole purpose is to calculate I, right? I is this. Now, what's the question saying? It's saying when R is 0, the current is 4 ampere. So R, now let's say, what is the value of I? I can be written as VTH upon R plus RTH, right? So when R is 0, VTH by RTH is equal to 4 or VTH is equals to 4 RTH, right? And when R is equals to 3, VTH upon 3 plus RTH is equal to 2 ampere. So that means, let's equate 1 and 2. So 4 RTH upon 3 plus RTH is equal to 2, which means 2 RTH is equals to 3 plus RTH, or RTH is equals to 3. You can solve with me and then, by yourself, and then compare the answers. That will be a good exercise. RTH is, and if you want me to stop somewhere and you want to solve it, let me know. We can do that too. And now it's saying for R equals to 5, what would be the current? So we can say VTH upon, since VTH is nothing but 4 RTH, 4 RTH upon 5 plus RTH is equals to I, right? So I is nothing but RTH is 3. So 12 upon 8, which
I'm
comes
very
out to be.
sorry to interrupt. So there was a
Yeah.
discussion which was going in one of the classes regarding the test regarding the proctored exam which is held. Sir, and they were saying some of the students that they didn't clear the previous one because questions came very different from whatever is done from whatever is given in the assignments. So, sir, how we need to prepare for that for the proctored exam?
Proctored exam is in the October, right? So questions were changed. I didn't quite get you.
No, they
Um,
meant to say that they
huh.
couldn't get their certificates. I am now currently in the first year, like
Oh.
in my second semester, but there are
Hmm.
students who are already in higher semesters and they couldn't clear the previous proctored exam because questions were coming very different from whatever are given in the assignment. So how we need to prepare for that exam? Can you please answer the question, sir, and clarify it?
Oh, okay. So it all depends upon your what you can say, this the person who is teaching this course, right? So I can't comment on that because I have not. So my how can I? So you can do one thing. You can write this in that discussion forum. So you must have received this link for that discussion forum, right, on your Gmail IDs or whatever you used to log into that Swayam portal, because the TAs of that instructor would be able to better answer this question. So I am an NPTEL TA. My responsibility is just to discuss sample problems and discuss questions, your questions regarding the week's lecture, right? So the instructor's own TA in that at IIT Kharagpur maybe are well aware with that fact and will be able to better answer your questions. So if you can write that in the chat box, it would be much appreciated. Or you can do one thing, you can send me an email at this ID, and then I'll forward it to that concerned instructor and the NPTEL team, and they'll get back to you immediately. So that's one thing you can do. So but what I feel is, if the assignments that you're solving are more than enough to answer the questions in the exam. Maybe the people who took that course would have find it difficult, but I'm sure it won't be the case with you. So you don't have to worry about right now. But yeah, but please do email me at this email ID, and I'll forward it to that concerned instructor, and he'll instruct his TAs at IIT Kharagpur to answer your questions. So I am not in a position to comment on the questions that come in the
The
proctored
question
exam
is
because.
regarding the electrostatic force.
Mm-hmm,
Can I ask you?
mm-hmm. Yeah, yeah.
Uh, Sir, in the electrostatic force, the formula which is K Q1 Q2 by R squared,
Mm-hmm,
the value of K is 9 into 10 to the power 9 Newton per meter square.
mm-hmm.
And sir, it's correlated with the formula of gravitational force, which is G M1 M2 by R squared. So the
Yeah, yeah.
value of G, that capital G is 6.67 into 10 to the power minus 11. So,
Mm-hmm,
sir, it has been found that in an experiment of the torsional pendulum, in the experiment of the torsional pendulum, the value of K and the value of G was found in a very similar way.
mm-hmm.
Will the answer be this that it was found in a similar way because in gravitational force, the celestial bodies also rotate and also rotate around the nucleus, like the electrons rotate. No, the celestial bodies rotate around the sun, and in the electrostatic force, the electrons revolve around the nucleus. So, is it the reason that both the values of the constants were found in similar way, or there is any other reason?
Renessa, so I really don't have an idea. So I know the concepts, but I won't comment on it because it's not my course and I'm not working in that area too. So I can't comment on that. But yeah, it will be better if you get in touch with someone at your college or you know I don't work in that area and so I can't comment on it. But yeah, from my previous knowledge, when I did that course in my BTech, yeah, something similar was there because both of those equations are similar in nature, or you can say it's the fact because both revolve around certain objects, right? But yeah, I can't comment on that. You can't ask me to comment on that because I don't have any idea on it. So please excuse me, it's not my area of research, and I haven't touched that subject in like 6 years now. So I won't be able to comment on it. Is that sufficient explanation to you? I mean, if you want me to go through the hassle of going through all of those books again and get back to you with the crystal clear explanation, I can do that. But yeah, I don't have an answer for it right now because I have lost touch. Renessa?
Okay, no problem then.
Yeah. So it's better if you get in touch with someone at the institute. Okay. So where was I? We were discussing something, right? I forgot. Yeah. So calculate this for me. What would be the answer? It would be 12 by 8, right? What is it? It's 1.5 ampere. See, I'll tell you one thing, Renessa. So this course that I'm taking, I too have to prepare for it, right? I also did it long back, but yeah, I know certain concepts and I can recalibrate myself, and then I'm in a position to solve those questions with ease and clear your doubts too. But I haven't been through that subject in like 6 years, so it won't be good for me and not good for you either to if I comment on that question. So it's better if you go to a much more experienced person or someone who works in that area. So, but if you want me to find that answer for you, I can do that. But then again, please don't believe me. I'm also taking the help of online material. I don't have any complete answer to that question. Yeah. Okay, so you understood this question? Seems like you already know how to solve it, so you're not interested. Okay, she left. Hmm, hmm. So it's again the question of maximum power dissipation. So how do we solve it? We would first find the So we'll do nodal analysis. So let's redraw the circuit. Hmm. So we need to find the open circuit voltage around these two terminals, right? So this is V1, this is V2, and this is V3. Now V3 is nothing but VOC, which in a way is Thevenin's voltage. So KCL at node 1. What would it be? V1 minus 45 by V1 minus V2 by 4 plus, okay, yeah. So what would it be? So can you tell me, so between V1 and V3, there is this voltage source connected, Vx. So how can we write the equations for it? Can anyone tell me quickly? Instead of me speaking, it's better if you speak. No? Okay. So, so can, can anyone tell me if the two between two non-reference nodes, if we have, let's say, what you can say, if we have this dependent source connected, can we treat it as this supernode, Renessa? So we are solving this question. So can you tell me if we have two non-reference node 1 and 3 and we have a dependent source Vx connected between them? Is it a supernode?
Yes, this is a super mesh concept. Super mesh.
Super mesh, we are doing nodal analysis. So we are doing nodal analysis. We took, just a second, we took a datum node and there are three nodes that we have taken, V1, V2 and V3. Now, since V3 is open circuited, and that open circuit voltage is nothing but the Thevenin's voltage. So we are saying V3 is nothing but Thevenin's this Thevenin's voltage. So can we take it as supernode?
Yes, we can take it as
Yeah.
super node.
Okay. Okay. So this current is going out of it, and this current
Sir,
is
one
going
more
out.
question, that why
Yeah. Yeah.
why in India the voltage rating is 230 volt and 50 hertz, whereas in Japan it's 110 volt, and also 230 is in UK also, in United Kingdom also, and but America also follows Japan's 110. So why is India's 230 volt?
So it's not just 110, it's 120 volt with 60 hertz frequency. So we follow 230 volt 50 hertz, they follow 120 volt 60 hertz, right? So that wasn't the case. So it depends on how you started producing electricity, right? They started producing it with the AC generators were producing it at 120 volt 60 hertz. So they continued that norm. The single phase voltage would come around to be 120 volts and 60 hertz. But India followed the norm of 230 volt and 50 hertz. There's no standards that dictate this. It's just that they follow this norm. So as far as I know, Japan had both 230 volts and 50 hertz and 120 volts and 60 hertz some places. It was either Japan or Soviet Union or Russia now. So what they did to unify the grid, so the grid has to be unified, they had to change their frequencies back. So since we are following 50 hertz 230 volts, we continued following that norm. It's not a standard that we have to follow. It's just how we started producing electricity, we continue producing electricity in that way. So you
Sorry,
must have also,
presentation,
yeah. Mm-hmm.
presentation, the capital V is volt, but whenever like an AC has both amplitude and frequency, right? So the thing is equal to V sine omega t. Now V is the amplitude, but the smaller V is the instantaneous. Like it's an international standard, right? So it's invariable, so it's instantaneous, which is a function of time. Now, while
Instantaneous, yeah.
representing that, suppose we why the plus and minus sign is there in AC? Because
Plus and minus
when
sign. Come again. Plus and minus sign. So you're saying that it's both plus and minus, right? So sine, if you take sine, for example, it rotates in both. It's for first half it's positive value, and for the second half it's negative value, right? So that's why they have both plus and minus. So
no,
I didn't get the question right. So can you come again?
no,
Hmm.
I also don't
Yeah.
know how to say this. That suppose the current is moving in one direction from B to A,
Okay.
and there is this AC current.
Hmm.
So why do we put the plus and minus signs? But it's alternating, right?
So we take a reference, right? We take a reference that since it's if it's going in this direction. So if it's AC, it's going in this direction, we call it positive. And when it's the reverse direction, we take it as negative. It's not, we have to do everything around certain reference, right? We can also, sign starts from zero, right? Yeah. So just a second. So we'll discuss this time series circuits too, three-phase circuits too, after some time after DC circuits is done. So sign is both positive and negative, right? So we take this as reference, this as reference. So you will notice about phasors and this reference where reference is taken for that phasor. So it's all it will come to you. The next week, I guess, we'll start this single phase and three phase circuit. So that's where your all those doubts will start. Your doubts will be cleared. But it's just that we need to take everything around certain reference, right? That's how we'll solve that whole problem. So our reference is this: we say the current increases in that direction, we take it as positive, and then when it reverses sign, we take it as negative. It's not. It's how it's the reference is taken.
So if the human body is enough to feel a current of 10 milliampere, right?
Hmm.
And then is 40 milliampere fatal?
I mean, I guess if a human body has this, if it can feel up until I don't know, it can feel up until certain milliamperes too. So yeah, it would be fatal. I mean, it's fatal because it can it interferes with your nervous system, right? So what is your nervous system? Nervous system is also some conducting some neurons from your brain to your different parts of your limbs or something like that. That's how you feel, right? So it's kind of a conducting system too. So it interferes with that, and that's how you feel the shock, and then interfering with that leads to fatal consequences.
So why is the impedance of an ideal voltmeter is infinite?
Ideal voltmeter is infinite
Yes,
in
the impedance of
impedance internal resistance.
no, the impedance of ideal voltmeter.
I come again. I can't. So for a voltmeter, okay. So we're deviating from our lecture, but okay.
The
12 volts,
impedance of
right?
an ideal is infinite.
Yeah, just a second, just a second. Let's say this is our voltmeter, right? So you're saying the resistance of it would be infinite.
No, the impedance, not the resistance.
Impedance, and so if in a DC circuit, what is impedance? What is impedance in a DC circuit? How do you write impedance? Impedance is some real value plus imaginary, right? Iota times imaginary. So for a DC circuit, there's no imaginary term. Real is impedance. So real part is nothing but resistances. So if I say for a DC circuit, impedance is resistance, so it's resistance, right?
No, and that in all
Hmm.
it already has in the current so that irrespective like of like leakage current there.
Okay, so your voice is breaking, but if you can write in the chat box, I'll appreciate. So I'm not able to hear you properly. So you're saying the voltmeter for that voltmeter internal impedance, let's say impedance is infinite. Hmm. I I I can't get you. Um. So can you once again repeat your question? I just want to clarify. So you're saying if there is a voltmeter connected across, let's say this part, 3 kilovolt, and there's this resistance, etc. Hmm. Yeah, if the internal resistance is infinite, it won't take any current, right? It'll act as an open circuit, right? So if it's not taking any current, that means if there is a resistance connected across these two terminals, whole current passes through that current that resistance, right? And so voltmeter is accurately able to measure that voltage across that resistance. So that is why internal resistance of a voltmeter is infinite or tends to infinite. Yeah. I guess this is the correct answer. Renessa?
Yes, sir, I got it.
Yeah. So you don't want any current to flow through it, right? Otherwise, it won't be able to perfectly measure what's happening to that because it's an external circuitry. You connect it yourself. So the circuit is not supposed to have a voltmeter inside it. You are connecting that voltmeter, right? So once you're connecting that voltmeter, you don't want it to have any current passing through that voltmeter. Otherwise, it won't be able to calculate perfectly the value of that the load across that resistance, right? So that's why the internal resistance of that voltmeter is infinite. And for ammeter, it would be different, right? You want the whole current to pass through that ammeter, right? So the internal resistance should be zero, so that the whole current passes through it, and you are able to correctly, accurately measure that current. Yeah. So when we are taking a detour, I want you to come to this topic. So I want you to tell me how to solve this question. So where was I? Mm, yeah. So between V1 and V3, so you told me it's a supernode, right? So can you tell me, applying nodal analysis as that supernode, what will we have? We'll have V1 minus 45 by 3 plus V1 minus V2 by 4 plus V3 minus V2 by 6 and plus V3. Oh, so this current is zero. So we don't have to, and zero, right? And also V1 minus V3 is equals to minus Vx, right? And applying at node 2. So it would be what? V2 minus V1 by 4. Are you solving it with me? V2 minus 12 by 2 and V2 minus V3 by 6. Okay, now what is Vx? Okay, so Vx is nothing but V2 minus 12, right? So we add over here, what would it be? V1 minus, sorry, V1 plus V2 minus V3 is equals to 12. Hmm. So we have three equations in three variables. So we'll solve it. So you to solve it so that therefore VTH comes out to be 90 volts. So since we have already applied to find Thevenin's, so we got VTH as 90 volt. Now we require to find RTH too. So for RTH, what we can do is we can take the same circuit and just calculate the Norton current. So for Norton current, what do? We short circuit that um, terminal. So again, so since the equations are somewhat similar, again supernode. So KCL will be what? V1 minus 45 by 3 plus V1 minus V2 by 4 plus V3 minus V2 by 6 plus IN equal to 0. Right? So what we are doing, we already found Thevenin voltage. Once we found Norton current, we can easily found Thevenin resistance. Right? So that's and what would be the value of V3? V3 is 0, right? Since it's short circuited, V3 is directly connected across the datum node. So the circuit equation becomes minus 45 plus V1 minus V2 by 4 minus V2 by 6 plus IN equal to 0. And we'll calculate similarly for V2. So Renessa, did you get the value of Thevenin? If you got, you can let me know. V2 minus V1 by 4 plus V2 by 4. Oh, so supernode we also require. So what would be the value? It would be V1 minus 0 equals to plus V3 equals to minus V. So it will be right. That's how we do it. So V2 minus 12 by 2 and right. So again, three equations in three variables. Can you solve it? sorry. Let's solve it. So it's 1/3, 1/3, sorry, 0.75, 1/3 plus 1/3 plus 1/4 minus 1/2 plus 1/6. This could be what? In is 1, right? This is, and this is 0. We have v1 minus 0 equals to minus vx. Okay, one more thing. Vx, what is Vx? Vx is nothing but v1 minus v1 minus 12, right? So equate this. v1 minus 12, v1 plus v1. So v1 minus v2 equals to 12, right? We're doing nothing. The same equation that we had earlier for when we were solving for VThevenin. Just equate V3 equals to 0 and take this extra current that's flowing through that short-circuited terminal, right? So again, 3 questions. So 1 minus 1, 1 minus 1. Oh, sorry. 1 plus 1, 0, and 12. And the last would be minus 1/4, 1/4 plus 1/2 plus 1/6, and which is 0. And hmm. Okay, so what did you get, Renessa? Did you solve this question? So iron would come out to be,
Sir, I'm solving the equation.
okay, you solve. So, and let me know the value of iron. So I've already solved. I'll check if you got it correct.
Sir, please give me some time. I'm solving it. Then you will tell the answer.
Yeah. You'd solve. Don't worry. I won't tell you the answer. So this is the first equation. This is the second equation, and this is the third equation. Just for your information.
V2 is coming 12.
Just tell me what is the value of iron.
It's coming 6 for me.
Iron. No. I think you're wrong. It's coming out to be a different value. I'll give you one more try. Let me solve it again, just so that I'm also clear. So it's V1 into V2 done, and then it's V1 plus V2 plus V1 plus one plus 1 12 minus 1 over 4. So it comes out to be 40, not 90. So did you get I in? Okay, let me solve it. 1 over 3, 1 over 3, 1 over 4, minus 1 over 4, minus 1 over 6, and V3 has 1 over V3 0. V1 plus V2.
Sir, I'm getting the same answer, which is 6.
Okay, so for me, it's coming out to be 110 by 7 amperes. So what were your three questions? Can you tell me? So if you write
7
it,
V1 minus 5 V2 plus 12 N naught is equal to 180.
okay, okay,
Then
okay.
11 V2 minus.
Renessa, just a second. Are you doing it on a calculator, right? Or you are using a
No,
Kramer's
no,
rule?
I am doing it. No, I am doing it by solving simultaneous equation and all, and
Okay, so,
substitution equation.
you're getting that wrong somewhere. So for my calculator, I'm getting IN is equals to 110 upon 7. So I would
So
request you
can
to
you
go
kindly tally the equations?
final equations. I'll tell you, right? Yeah, that I can do.
7 V1
Just a second. What were you saying? 7v1. Let's do it. I'll do it on with you. So I was
minus
using a
5
cal.
V2 plus 12 N naught is equal to 122. E2 is equal.
Yeah, so we'll do it together. It's just that I was doing it on calculator, so I didn't write final equation. I just simply did the maths. So for the first equation would be, let's write this first, right?
I am telling you. 7 V1 minus 5 V2 plus 12 N naught is equal to 180.
Plus 12 IN is equals to 180.
180.
And then your
Then
the
the
next.
second is 11 V1 minus V2 is equal to 12.
No, V1 plus V2 equals to 12, right?
Oh, V1. Okay, wait.
Yeah, yeah, that's where you got it wrong. And you can tell me the final equation too once so that I can quickly solve and we can check if both are correct or wrong. So your first equation is correct, definitely. I need your third equation. Or if you're doing it on your own, let me know.
So it's coming 110 by 7.
Yeah, great. So that's what the answer is to. So we got both VTH and IN. So can you tell me what is the value of RTH? It would be VTH upon IN. So since VTH is 40, IN is 110 by 7, the value comes out to be,
Wait, I am telling.
yeah, you tell. I'll calculate so that, hmm.
28 by 11.
Yeah, 28 by 11 or 2.545, right? So keep your calculator with you. I mean, the calculator is one thing that you would be needing in your exams too. So people generally don't have any apprehensions about calculators being used in the exam. At least wasn't the case with
Sir,
me.
actually, I left the calculator in my home basically. So now currently I'm in my hostel, so I have to do something.
Okay. No worries. So you can. So do you know how to use MATLAB?
No, I don't know.
Oh, no worries. So there are multiple ways. So yeah. So can you tell me quickly now? You know VTH and you know RTH. So can you tell me what is the maximum power, which is VTH square by 4 RTH? So now you're getting the feel of it, right? How we solve these questions. So
It's 1100 by 7.
yeah, I want an exact value because the question is like that. 157.17, right? That's what comes out to be what? So if you see, it's what's the answer? The answer is B part, right? Because it's between 154 and 160. So let's do one more question. So now you're getting the feel, right? How you
Sir,
solve
what is your MATLAB, sir?
what is MATLAB? Yeah, I shouldn't have brought that term since you are a first year student. So I guess in your fifth or sixth sem you'll be made acquainted with what MATLAB is. It's like a it's like a programming based or you can say it's a programming based software where you do programming in like matrices. That's how it comes out to be MATLAB. So it's like you give a workspace of matrix and then you solve the so you'll be made acquainted in your fifth sem. You don't have to worry about it now. I lost the plot that you didn't study. Yeah. So it's
So
saying
what interface does it have? Like, do we need to learn any programming language beforehand? Like, it does use Python interface or something?
no. So it's a completely different programming language. It's sort of a mixture of Python and C++, and it's like a different programming language. So it's very neat. You don't have lot of syntaxes. It's like a very neat programming language where you can easily code any mathematical properties or any mathematical functions or anything. It's used mainly for simulating stuff. So you will be made acquainted if you want to go through. If you want to do it, you can do it on your own. There are several YouTube resources where you can um, get to learn how to use MATLAB. But if you so I can recommend one book that I followed when I was in my fifth sem. So I used books. No, I don't like YouTube tutorials, so it's such an irony. I am giving YouTube lectures. So that book made me appreciate MATLAB, and I got to learn MATLAB through that book only. Now I'm no longer using it, but that doesn't mean that it's not a good programming language. So yeah, just remember one thing: get used to a good programming language because it certainly help you when you go for a BTech UG project. So, any more questions? Okay, we'll move
So
ahead.
what's that book you said?
I don't remember. Let me. Um, um, it's it's by Brian Hunt and Ronald Lipsman, a guide to MATLAB for beginners and experienced users. So You can definitely go through that book and you'll be. So I'll just add this book. You can learn. Hmm. Can we solve this question? I mean, I seriously want you to solve this question so you are able to solve the week 5 assignment. So we're lacking behind. Okay, so what are we given? We are given um, some resistance, load resistance, and we are said that it absorbs a power of 20 watt, right? And we know that R is greater than 5 ohm. These things we know. So we need to find the value of R. So how can we find Renessa? So we can convert it into a Thevenin circuit and then find the value of power. Otherwise, also you can do all of those nodal analysis and mesh analysis, find the current, find the voltage, do P equals to I square R. But going through Thevenin, since you are being made familiarized to a Thevenin theorem, it's better if you solve it through that. And computationally, it would be less extensive. So let's solve it. So we'll name the nodes. We'll solve it using nodal analysis only. It's the best method I find. Plus minus 2bx. So you're doing it with me, right? Hmm. So the first thing we do for nodal analysis is find out the datum node. This is V1, this is V2, and this is VOC. Or we can simply write VTH, right? Hmm. So since the terminal is open circuited, what is V2? V2 is nothing but VTH, right? Since it's open circuited, no current flows through 2 ohm resistor, and the value of V2 will be VTH only. So let's apply nodal analysis at node 2. This is not a node. I don't know why I wrote this as node. This is the only node. Hmm. So at node 1, let's apply KCL. So V1 minus 2Vx by 3 plus V1 minus 20 by 1 is equal to 0, right? Since there won't be a current flowing to that 2 ohm resistance, it would be 0. And yeah, so what is V1 in terms of, right? Now, can you tell me what is the value of Vx, Renessa? It's 0, right? Because no current is flowing through it. So 2 ohm resistance would be, so the voltage around 2 ohm resistance would be 0. So Vx is equals to 0. Therefore, V1 is nothing but 60 volt. That means VTH is what? 60 volt. All right. Hmm. Now let's find RTH. So how can we find RTH, Renessa? Renessa, how can we find RTH? So we'll short circuit it, find the Norton current, and we can find the RTH. Let's do that. So let's short circuit it, let the current be IN. So let's write KCL. So the pace is not fast, right, Renessa? KCL. node 1. So what is it? V1 minus 2Vx by 3 plus V1 minus 20 by 1 plus In equals to 0. Right. Now tell me one thing. What is the value of Vx in terms of V1? Oh, sorry. What is In terms of V1? In is nothing but V1 upon 2, right? Since it's connected to datum node V1 minus 0 by 2. And since In is 0, what is Vx? Vx is nothing but 2 into In, which is equals to V1, right? So let's equate everything in that first equation. So this would become V1 minus 2Vx, which is 2V1 by 3 plus V1 minus 20 plus V1 by 2 equal to 0. This would come out to be V1 1 plus 1 by 2 minus 1 by 3 equal to 20. So what would be the value of V1? 1.5 minus 0.33. 7 by 6 or V1 is equals to 120 by 7. 7 by 6, right? So you're solving, right? Is it correct? Therefore, In comes out to be what? 60 by 7. So RTH is what? Can you tell me? VTH by In? What was the value of VTH? It was 60. So 60 over 60 by 7 is nothing but 7 volts. Oh, sorry, 7 ohm. So the question was, we needed to find the value of R given that, yeah. So VTH is what? VTH is 60 volt, RTH is 7, and we have some R, and it absorbs 20 watt. So Ranesa, how will we solve for R? Right, and it is given out to be 20. So let's solve this. So 360 square R is equals to 49 square plus 14 R plus R square, right?
Sir, kindly wait. I'm
Yeah.
having.
Do. So you're doing it with me, right? If you're doing it with me, is V1 correct?
None of the answers of mine are matching.
No, but so I made a mistake and you didn't clarify. So if you're doing it with me, is my V1 correct? So what I've written, is it correct? Or did I miss something? I missed something, right? It's 1
No,
by
no,
3 plus 1.
my answer is not matching with you, sir.
Yeah, so what would VTH come out to be? What is VTH for you? It's 3 by 4, right? So it would be 60 by 4. So 60 by 4 is 15 volts. So VTH is 15 volts, right? So your VTH came out to be 15 volts?
15 by 60 by 7.
Yeah, so yeah, that would be 50 by 16 by 7. Yeah,
It is
correct.
7 by 4 answer. 7 by 4.
Yeah, 7 by 4. And this would also be 15, 7 by 4. So can you tell me what the equation came out to be for you? Very
No,
good.
you
If you're
don't
doing it,
write it.
yeah, since you're doing it with me, that's good. Otherwise, I would have not able to find what my mistake was. 7 by 4 ohm. Now tell me. So it's 15 squared 225 R equals to divided by 20. So that becomes 49 square by 16 plus R square plus 2 4 16 by 4, which is 7 by 2, right? 7 by 2 R. Let's solve this equation. It is nothing but 1. R is either. So, yeah, you're doing. So, let me know once you find the answer. Remember, R is greater than 5 ohms. So, it's an equation with the order. It's an equation of order 2. So, there will be 2 R values. So, you have to negate one since you are already given R is greater than 5. Now, tell me, what did you get the value of R as? Renessa, did you get the value of R? Or you're doing it by hand? You don't have to do it.
So
Once
it
you
is
get the
coming 3488 R is equal to 418 R square.
Okay, so I assume it's correct. So the answer would come out to be 7.33 or 0.418, right? So since R is greater than 5, the value of R is nothing but 7.33 ohms, right? So that means C option is correct. Let's do one more. So now you're able to understand how to solve Norton and Thevenin circuits, right, Vanessa?
Yes, sir. But sir, when it comes to a question, I don't know why, but I'm not confident with this, particularly these two theorems.
Yeah. So this confidence comes with solving more and more questions, right? What we are doing is right now, I'm just acquainting you with how to solve these types of questions. That doesn't mean that when you go, once this class gets over, you have to solve some questions on your own too. So it's better if there's this book, Alexander Sadiku, right? The one that's being referred by the instructor too. So you have to solve the questions given in these exercises too. So that's how you will be able to be more confident once you solve these questions. Otherwise, it will all be, you won't be able to appreciate how to solve these questions. So again, here we are given the same equation. We need to find the value of R, and we are saying the maximum power that can be delivered through the RL resistance is 10 watts. So since it's a maximum power transfer theorem, again we'll find the Thevenin equivalent circuit and then apply the analysis, right? So quickly, let's find out what would be the Thevenin voltage. Let's do it.
Sir, is this a Wheatstone bridge? I mean, this is not a Wheatstone bridge because the ratios are not maintained.
Okay, so pardon, I didn't understand. So what did
This
you say?
is not a Wheatstone bridge, right? This is not a Wheatstone bridge. The ratios are not maintained.
This is, oh no, it's not a Wheatstone bridge. The ratios are not being maintained, right? It's one is to one, and the other is 3:1. So it's not a Wheatstone bridge. And otherwise, also, it's the load resistance has some power, right? If it has some power, that means it's not a Wheatstone bridge. So in a Wheatstone bridge, what would happen? The RL wouldn't have any current passing through it, so it won't have any power. Excuse my drawing, I'm not okay. Yeah. So we've drawn the diagram. Now we need to find the Thevenin voltage. So tell me one thing, since the middle bracket is opened, we need to find the open circuit. The circuit is nothing but the upper limbs have the circuits in series and the lower limb have circuits in series, and the upper limb and the lower limb is in parallel to each other. So we can easily find the current I. I current is nothing but, so first we'll find the R equivalent. R equivalent is what? 4R parallel to R, right? 4R parallel to R. What it be? It will be 8R square by 6. So 8 by 6R or 4 by 3R. So I is 40 divided by 4 by 3R, which comes out to be 30 by R, right? So can you quickly tell me what is the value of I1 and I2? So it's 4:2, right? So what would be the value? Four is to see two, the value would be I1 would be 20 by R and I2 would be 10 by R, right? I hope this is correct. Hmm. No. I1 would be 10R and I2 would be 20R.
Sir, you reversed it.
Yeah, sorry. So I didn't solve it, right? I just simply took the. So I1 is 10R and 10 by R and I2 is 20 by R, right? So now to find VTH, what will we do? We'll use the KVL and we'll apply it in the loop 1. So while applying KVL, what would be the value of VTH? VTH would be I2R minus I1R, right? So can you tell me what is the value of VTH? 10 volts. Did you get VTH 10 volts? Hmm. Yeah. So now we'll find the RTH. So you can solve it on your own and let me know what is the value of RTH. So I'll also do side by side. I'm giving you a head start. So let's find the value of RTH. So to find the value of RTH, I'll switch off my independent sources. Hmm. So how will we do it? So since these are connected to each other, short circuited, so I've represented both of them with the similar nodal value. So because both are similar nodes, B, right? So how do we do it? So it's can I can anyone tell me how do we solve this question? How can we solve the R equivalent value? We'll redraw the circuit, right? So we'll start with node 1. This is our node 1. After that, A is connected, which is also node 1 only, but let it be A. And with that there is R connected to node B, right? And with node B we have R connected to node C. And it is connected to node 2, right? Now C also has R connected with B over here. So I drew like this. Now let's draw it like this. So B has R connected with C. So this is R, and A has 3R connected with. So now can you find RTH? RTH would be 3R by 4 plus R by 2, right? Is this correct? Which is equals to 5R by 4, right? So now it is saying the maximum power that's transferred is nothing but P max is 10 watt, which is equals to VTH square by 4 RTH, which is equals to 10, right? What is VTH? We calculated VTH, right? VTH
It will
was
be
10.
10.
Yeah. So your what exactly? Yeah. So you found the value of R. I didn't quite get you. So what were you saying?
RTH is equal to 5 by 2.
5 by 2? No, it would be 5R by 4. Can you check again?
No, RTH will be 5 by 2.
No, my RTH came out to be 5R by 4. Can you check again? That's what I'm saying. So this is the equivalent circuit, right? The one that I've drawn over here. Did you check the circuit?
No, actually, I was doing mine, so I didn't see.
Yeah. So how do you solve the circuit? I'll repeat. So one node is connected directly to A node. So I
No, I
represented it
was
with it.
seeing the YouTube video. I was seeing the YouTube video. You solved the other questions also.
Oh, okay. Great. So VTH square is nothing but 10 square, right? So it's 100 upon 4 into 5R by 4. So which implies R comes out to be 100 upon 50, which is 2 ohm. So that means the answer is A. Great. So let's solve one more question and then we'll. Hmm, hmm. So how will we solve this question? Again, with the help of what? We are required to find Thevenin's equivalent circuit, right? So it's already open circuit, so I won't draw it again. So these two nodes are together. Let's call it V2. This is V1, right? So can we write an equation KCL at node 1? So I want you to solve it. So uh, you don't have to worry about the class getting late. I want you to solve it so that you are comfortable solving Thevenin circuit. So solve it with me. And so V1 minus 10 by 1 plus, oh, V1 is directly given. V1 is nothing but 20 volt, right? It's directly connected across to this voltage source. It's 20 volt. Then it's nothing but let's calculate only V2. So V2 minus 20 by 2, and there's 6 ampere current going. That's V2 by 2. And no current will flow to that 1 ohm resistance because it is open circuited. So what is the value of V2? It comes out to be 4 volt. So is it safe to say VTH is 4 volt? Because it's directly connected to that open circuit. So VTH is 4 volt. Now that means C and D can't be our answers. So I want someone to solve for RTH. It's easy, right? 1, So it's 1 ohm, 2 ohm, 2 ohm, and 1 ohm. It's very easy, right? Can anyone solve for RTH? Inessa, I want an answer from you. So this 1 ohm resistance is in parallel, is in series with the parallel connection of these 2 ohm resistances, right? So what would be the answer? The
Answer will
answer,
be option B.
yeah. So the answer is B. Great. So we still have 6 minutes. So let's solve one more question. Yeah, this question. Hmm. So what are we given? We are given that there is circuit A, which has an 18 volt voltage source and series with a 3 ohm resistance, and the other circuit is some circuit, right? So we need to find the maximum. We need to find R at which circuit A is supplying P max to circuit B, right? So, can you tell me if I consider circuit A, right? So let's think for a moment. The circuit A is if it's for its VThevenin and RThevenin, what would it be? Its VThevenin would be for circuit A. VThevenin. Can you tell me, Renessa, quickly what would be the value of VThevenin for circuit A? Since it's just a voltage source in series with the resistance, right? What is a Thevenin circuit? It's a voltage source in series with the resistance. So VTH would be 18 volt and RTH would be 3 ohm. So for circuit A to supply maximum power, what should be the value of RL? Let's consider the circuit B can be represented by an RL circuit, some resistance, right? So what is it? It's 3 ohm, right? That's when Pmax, yeah, that's when Pmax will happen, right? So now let's calculate I. For that matter, the current I coming out from that circuit would be, let's call it IS. What would be IS? VTH upon RTH plus RL, right? And what I just did, I represented circuit B by some resistance RL, right? For circuit A to supply maximum power, that RL must be equal to RTH, right? So IS, the current coming out from that circuit A would be nothing but 8 upon 6, which is 3 ampere. Yeah, it's 3 ampere.
Sir,
So
I
what
am
is this?
saying, but you are getting it late.
Yeah, so your voice is coming late to me, so your voice is breaking too much. But yeah, you're correct. So it's great. So can you tell me what would be this value be of V naught? Since RL is what? 3 ohm, the value of V naught would be 3 into 3, 9 volt, right? Now tell me if I have this circuit, can you tell me what would be the value of R? How will you tell me? Okay, so I guess you're not able to understand. So I don't have much time. Okay, I'll do it. So V naught is nothing but 9 volt, right? The RL is 3 ohm and the current coming out of it is 3 ampere. So V naught is 9 volt. So we can do nodal analysis around this node. So V1 minus 9 by R plus V1 by 5 plus V1 by 6 would be equal to 0. Is this correct? Renessa, is this correct?
No, I'm not understanding it. I'm not understanding.
You're not understanding it. Okay, just a second. Let me do it like this. So this V naught is 9 volt, right? So the current entering this terminal is what? 3 ampere. Is this sufficient for you right now? 3 ampere is coming into the circuit, right? Circuit B. So if I apply a nodal analysis across V1, what would it be? V1 by 5 plus V1 minus 6 by 1 minus 3 ampere, right? So we can find the value of
Yes.
V1. So V1 की value कितनी आएगी? 1 plus 1 by 5, which is equals to 9. So V1 is equals to 5 by 6. 9 into 5. 7.5 volt, right? Now I know this current entering this circuit is 3 ampere. So I know V naught is 9 volt. So what would be the value of R? We can calculate it using V naught minus V1 by R is equals to 3 ampere. V naught is what? 9. V1 is 7.5. R is R. And R will come out to be 1.5 by 3, which is nothing but 0.5. Were you able to follow? So what I just did, I represented circuit B as a as a as a resistance RL. For power to be maximum, RL must be equals to RTH. That means RL
It
was
will
3
be
amp.
2, right? The answer will be 2. No,
No,
no.
it
The
would
answer
be
will be 0.5.
0.5, right? So the answer is B. Great. So I hope you understood it. So are there any questions? So I need to close it. It's already 5:56. The other person has to take the class at 6. So are there any questions?
No, sir.
Okay, great. So you can
Sir, if
you
there
may
are
leave.
any questions after the assignment you solve, because we also solve from other books as
Yeah, yeah, yeah. Yeah, you should solve it from
then
other books. If you have any problem, you can write to me, right? You have my email address, or you can post it in that discussion forum also. I can check it and I can reply to you. Okay,
so what
so
is that discussion forum, sir?
discussion forum. So you must have received when you were this this so you receive so you don't receive, so don't worry about it. You just send it to my email address and I'll sort it out for you. You don't
Sir,
have to worry about it.
below your YouTube video, below
Yeah,
your YouTube video.
yeah, in the comment box as well. You can use that too. No worries. Okay, so now there are no more queries. I would request you to log off. So I want to end this meeting. So can you all log off?